Okay, let's find the definition of torque. We still don't know its definition. We need the formula to be able to define it, but as I said, formulas are definitions or statements. And in here, for now, I know that the torque is a cause for rotation. So there is a, like this wrench is trying to, of course, rotate in here. If I like move, like if I apply force this way, it will rotate. And if I apply force like this, of course this part is the pivot point, which is completely stationary. This one wouldn't rotate, only this one rotate. This part, the rest of the wrench will rotate, and of course it will be like this, right? So it goes like part of a circle. Therefore, from the wrench to the part where the force is applied is usually called R, which represents a radius, because it actually goes like a circle, right? It's a part of a circle, this rotation, and this would be the center of that circle that goes like this. So and something, let's find the formula by having a better look at this torque. If I apply force here, like if I am trying to like grab it and move it like this, so my force is here, and I can also apply force here. Of course, if I applied my force here, this would be my R. My R would be from here to here, let's say this would be the R, right? And this point, I mean, I can take this point into consideration, or this point, doesn't matter really. Maybe this point doesn't matter, but it's not a big deal. The main point is that what I am trying to say is that now if I apply my force here, so if this is like the same force but is applied this way, if I grab it and try to rotate it this way, is much better torque, is much easier to rotate it, right? So better torque is given when I am further from the pivot point. So you know that if you imagine using a wrench, you can realize that. And I call this R1, and from here to here R2. Of course R2 is bigger, so I have a better torque. So the torque, I can see that has a direct relationship, and torque is, we show it like this. This is how we show torque. The torque has a direct relationship with the R, with the radius of this circle that I just showed you, or the lever arm. It's also called lever arm. So the bigger the lever arm, or R, is the same thing. Sometimes they show it with L actually, but the same thing. So anyways, now let's look at the F and see what role F will play. Of course, torque has a relationship with F too. The bigger the F is, of course, the easier the rotation would be. So the bigger the F is, like if this is a small f or this is a big F, of course the bigger F will give a better rotation. So I can say torque is also has a direct relationship with the force, but let's play with force a little bit more, because not only magnitude of the force but also the direction of the force. Let's say the force is applied here. As I said, it can be bigger. The bigger it is, the more effect it has. But the direction of the force, let's say if the force is applied like this, or like this, or like this, of course if the force is applied like this, like if you try to drag it this way, it wouldn't cause any rotation. I just not doing anything for our purpose, which is the torque, so it wouldn't help our torque. If it's like this, now if this is my F and has an angle with the lever arm, of course this is my lever arm, right? So if this one has a angle with this lever arm, theta, let's divide it to its components. Of course this is fx, which wouldn't do anything for me. This is Fy. Fy is the one that does work for me. Fx I don't even write, I don't care. Fy is the one that does the work for me. I mean, causes the torque for me. So the Fy is causing the torque for me. Let's find out what is Fy. Of course, in this rectangle, you can see that this is equal to this one, which is the opposite to the theta. So the opposite reminds me of sine. Sine of theta equals opposite over hypotenuse, and sine of theta equals opposite in here is equal to Fy over hypotenuse, which is the f itself. So the Fy equals Fy equals f sine theta. Yeah. So I should say what actually causes the torque is f sine theta. So I'm just writing here f sine theta. F sine theta is what is actually causing the torque for me. So I should say that torque has a direct relationship with f sine theta. And if I want to write an equation for it, actually this is actually the equation of the torque, but you'll see why. But R F sine theta, this is the equation of the torque. This is the radius, this is the force, and this is the sine of the angle between the force and the lever arm. So angle between F and the lever arm.